This example is called the facility allocation. Suppose we are about to allocate some facilities in a network, and each node should have that specific facility, or at least one of its neighbors or connected nodes has that facility. So we want to find out the minimum required number of nodes to allocate these facilities. So here you can see a given graph with, if I'm right, there are 19 number of nodes, and we want to find out what is the minimum required facilities and which one of them are the best one to allocate that facilities. So I define a binary variable called xi, and we want to minimize the summation of that, and for each I, xi plus summation of xj should be bigger than 1, but summation of xj is done in a specific way, only those j's that are connected to I. So we are doing the summation over the neighbor nodes. Okay, so let's have a look at the code. So here I import the required packages like networks, matplotlib, and these two are required for plotting this graph. So the one random graph is plotted here, and then the other packages are imported here. So since we have already imported that one, it's not needed again. And also I run this one as well, and then I will create the abstract model. N is the number of node, which is initialized with the G node, length of G node. I and J are set representing the nodes. L is the connection matrix. X and Y are the decision variables. Y is actually the objective function as well. X is a binary variable, and this constraint is created, as you can see. Look at this one. If Lij has value equal to 1, then the summation is going to happen. So you can see that the model, also the final one, y is bigger than summation of xi. I could say equal to that, but that will give the same results. So in this tab I am feeding the data into the model. Okay, so I run this. Here I do have the edges in the graph, so I create the lines, and the lines will be fed in that dictionary, which is going to construct the data for me. Okay, and the solver is glpk because it's a linear kind of programming. And then we can print that. It means that the nodes, there are 7 nodes required for this specific graph, and the chosen nodes are like this. Here you can get some information regarding how the model is solved, is it feasible or not, and finally the final solution is given here. So you can see that the selected nodes are specified with yellow color. For example, if you look at the node 2, the neighbor node has a facility. Node 7, the same. Node 14, the same. Node 12, the same. So node 16, the same, and so on and so on. Okay, and that's it for this example. Thank you very much.